So continuing on to part B for question 8, we now want to find to the nearest minute the earliest time the boat can leave the harbour. So we are told that the boat requires the depth of water to be at least 3.8 meters before it can leave the harbour. So that means our D here has to be 3.8 meters for us to find the corresponding value of T, so we can then work out the actual time that it leaves the harbour. So let's first substitute in our value for D. So that's 3.8. So 3.8 is equal to 5 plus 2 sine of 30t. Okay, so now we're going to solve this as we would a normal trigonometric equation. So make sure all the constants are on one side, and then once we get to our trig function, we can apply arcsine to get little t. Okay, we're just going to have to be a bit careful, as we'll see. So 3.8 minus 5, we'll do 3.8 minus 5 first, equals 2 sine of 30t. And you can write what we have on the right hand side, you can just put it on the left, so you can kind of rewrite this as 2 sine 30t, as long as you move everything on the left onto the right as well, and that might be easier for you to work with your terms. Okay, so 3.8 minus 5, so that's 2.2. Sorry, that should be 1.2. It's not 2.2, 1.2. And then we have sine of 3.8 minus 5, that's minus 1.2. Let's just be very careful there. And then we're doing 2 sine 30t equals minus 1.2 divided by 2. So we get sine of 30t equals minus 0.6. Okay, so we want to now use our arcsine function on our calculator to calculate our value for t. So 30t will equal arcsine minus 0.6. So use the calculator to see what that gives you. Arcsine of minus 0.6. That's going to give you minus 36.869. ... So you might be tempted now to just divide through by 30, and that's your value for t. Now, if we just stop for a second and have a look at what this is saying, it's saying a value for time, or time t hours after midnight, is a negative value. So then this can't be the correct value for t that we want. So if we kind of look back at this expression here, this is our equation for sine. So sine of 30t equals minus 0.6. If we draw our sine graph quickly, just a small rough sketch, and we want a negative and a positive quadrant to help us here. So our sine graph's going to look something like this. And then the negative part, something like that, and it will continue. Now, if we just ignore that it's 30t, just imagine it's sine of some function. You can call this sine of x, really, if that helps you, equals minus 0.6. So on our graph, x, y graph here, minus 0.6, let's think of it as being somewhere here, minus 0.6, right? Like that. And of course, this is 0, this is pi, this is 2 pi. It might be better to do everything in degrees, actually. Oh. And so this is 0, this is 180, this is 360, this is minus 180 degrees. Sorry, that's our y value of minus 0.6. And this is minus 360 degrees. So our x-axis is in degrees, our y-axis gives us the values when we input our x into our sine function. Okay, so when we applied our arcsine function to get minus 36.869, that solution comes from here. So for the line of y equals minus 0.6, or for the value of minus 0.6, the corresponding x value on our sine graph will be minus 36.869, and so on. So we're going to have to use the periodicity of sine x to find the corresponding value that we actually need, because this is the principal value that doesn't mean much to us in terms of describing the physical quantity that we want. In this case, it's time. So what we can do here is we want to look at the corresponding solutions that actually give us positive values, or will give us positive values for t. And it's this one here and this one here. Now, if we have a look at this, so that solution there will be 180, because obviously where the sine graph is crossing the x-axis, that's going to be our 180 degrees. So this solution here will be 180 plus 36.869, like that. If we do a quick calculation of that, that will mean we have 30t equals 180 plus 36.869. Doing 180. You can just plug that in the calculator. We're at 216.869. We divide that by 30. We get a time of 7.22 ... Okay, we are told in the question that once the boat enters the harbour, it does take 2 hours to load its cargo. So it can't leave until after the time of 8:30 a.m. So in fact, we need to take a value for t which is greater than 8.5. This value that we've just calculated, 7.22, is less than 8.5. So that's also not the solution we want. In fact, it's going to be this one here. So this solution here is the one we want. And that's going to be 360 minus 36.869. And so we'll get 30t equals 360 minus 36.869. So that's going to be 323.131. Dividing that by 30, we get 10.77 hours after midnight. Therefore, our time will be 10:46, because that's 0.771. It's roughly 10.77, and that's going to be around 10:46 a.m.